These are additional examples of the change of base formula. This is the change of base formula, and this is examples of how the change of base formula is used. This would be equal to the log of 32 divided by the log of 15. In order to get the right answer with your calculator, you must close the automatic parentheses. You would pick up your calculator, press the log button, put this in your calculator, make sure you put the parentheses, and round it off to 1.2797. It says 3 decimal places, so this 9 would round to a 10.280. This would be the log of parentheses 125 divided by the log of 17. You must have the parentheses to get the right answer with the calculator. So this is going to be approximately equal to 1.704. I just put it in my calculator, rounded it off. This is going to be a log of 14 divided by the log of negative 2. You must close the automatic parentheses, and the calculator will give you an error message. That's because this is undefined. You cannot take the log if you have a negative base. To use this to solve problems, I will take the log of both sides of my equation. I will use the power rule to bring the x out in front. To solve for the x, I will divide by the log of 15 on both sides to cancel that out. That log of 15 stays together. And so this would be the log of 20 divided by the log of 15. Log of 20, close parentheses, log of 15, close parentheses. X is approximately equal to 1.1062. You can check by putting 15 to 1.1062 in your calculator, and that will approximately be equal to 20. 15 raised to the power of 1.1062 is 19.998, which is approximately equal to 20. It's not exactly equal to 20 because that's a rounded off number. Take the log of both sides. Use the power rule to bring the 3x out in front. Divide both sides by the log of 4. When you put it in your calculator, make sure you close the automatic parentheses. So 3x will approximately equal to 1.3219. Divide both sides by 3. And that's 1.1073, approximately rounded off. To solve example 6, I will take the log of both sides. I will bring the 3x minus 2 out in front using the power rule. I will divide both sides by the log of 5. So with my calculator, I say log of 30, close parentheses, log of 5, close parentheses, 2.11328 rounds to 3. Add 2 to both sides. Divide both sides by 3. Round it off. Example 7, I will take the log of both sides. I will use the power rule to bring the 2x plus 5 out in front. I will divide both sides by the log of 4. Not just 4, but the log of 4. That cancels out. 2x plus 5 equals log of 10, close parentheses, divided by log of 4, close parentheses. With my calculator, round it off to 1, 2, 3, 4. This would be 0.96, and so 1, 2, 3, 4. That's going to round the 9 up to a 10. 1.66. This 6 rounds the 9 up, the 9 rounds up to a 10. Subtract 5 from both sides. So that would equal negative 3.3310. Divide by 2, and x is approximately equal to negative 1.6695. You might get a little bit different answer because of rounding.